You now know everything you need to know about the law of sines and cosines. We're going to do some story problems today. Actually, there's one thing that I don't think that I've told you. When does the law of sines work? Angle, side angle. Side angle, side actually doesn't work. Angle, angle, side. And then, of course, angle, side, side. And we're going to talk about that again today. I may have said yesterday that sines did side angle, side, but that's not true. So if I said that, I apologize. When does the law of cosines work? Side angle, side. Side, side, side. What about angle, side, angle? Or angle, side, side? It does, but we've never done one like that before. So, well, you might actually prefer it. Let me show you. I'm not going to draw a triangle. I'm just going to fill it in. So, b squared equals a squared plus c squared minus 2ac cosine of b. Now, I'm just going to plug this in with really nice numbers just to show you how you would do this. So, maybe I need to draw the triangle. So, yeah, that's a big B. So if B is known, cosine, let's make this easy, 60 degrees, and little b is known, we'll say 5, and call this A and this C, and either little a or little c is known. It doesn't really matter. So I'll call little a 60 degrees. I'll call it 6. I'm just guessing. So, good thing that's not on the video. So if I fill this in, 5 squared equals 6 squared plus c squared minus 2 times 6 times c times the cosine of 60. Does anybody know what the cosine of 60 is? You don't remember from your unit circle days? 0.5. So times c times 1/2. Now, normally that number is going to be a little bit nasty, so whatever. I just made it nice. So I have 25 equals 36 plus c squared minus, those cancel, 6c. What do you notice? It's a quadratic, right? So I'm going to move the 25 over. So subtract 25, that's going to be 11. So 0 equals c squared minus 6c plus 11. So there are two potential solutions, right? Well, how do you know that this particular triangle has no solution? Well, how would you find the roots of this first? Well, you could factor it. Well, the chances of it factoring, though, are none. It's just not going to factor. I mean, it would have to be really, really set up. And in fact, who knows? Maybe there's a way to make it factor, but my guess is there's no triangle that has nice angles and nice sides at the same time, unless it's equilateral. So it probably will never factor. So we could use the quadratic formula, or we could complete the square, or the easiest way would be to graph it and find the roots. So let's not bother. How do I know, if I graph this, how would I know that this triangle does not exist? It doesn't have any roots. So if I graph the quadratic and it misses the x-axis, that tells you that the original triangle is impossible. Okay? How do I know that it has two solutions? That's not enough. Hitting the x-axis twice is not going to be enough. So if it intersects like that, what do you know? There's one solution. How come? Because can little c be a negative number? No. So that would mean one solution. What else would mean one solution? If it bounced off the x-axis, then it would have one solution. What if both roots are negative? No solution. So what must happen in order to have two solutions? They're both positive. So if you prefer that, then you don't even need to find the angle. So if we find out, well, did anybody graph that? Does it hit twice? It misses? No, that can't be right. No, I guess it could be. Yeah. Let me see. You missed an X. Yeah, it misses. Okay, so this actually has no solution. Well, what if that was a 4? Oops. Here, I have a calculator. Why am I using yours? Sorry. So, that way everybody can see. So if it hits once, that's the answer, and you find the other angle using the law of sines and law of cosines. But x squared minus 6x plus 4, we graph that. Both of the roots are positive. So let's say the one is 1.8 and the other is 1, 2, 3, 4, 5.1. So if I get c equals 1.8 and 5.1, and the nice thing about this is you don't have to run the test. You don't have to do the bigger than and the pivot and all of that, because if I knew little c was 5.1, that's obviously the triangle I've drawn. And then if little c is actually 1.8, then the other triangle builds itself. And this is 5. So you might actually prefer doing them that way. I'd never seen that. I came up with this today. I've never seen anybody do it this way, but personally, I'd rather solve a quadratic than remember all the rules for that silly test. So whichever way you prefer. And just remember that this angle is known, so it doesn't change. So the 1.8 is off of B instead of off of A. And then you can use the law of sines or the law of cosines to find the other two angles. Well, one angle. Once you know the one angle, then you can find the other one. Does that make sense? All right. This worksheet is kind of tough, but it'll be good for you. Story problems. But you need to know a couple things. If I were looking at a map, where are the cardinal directions on a map? North is up. South is down. That's easy. East is to the right. West is to the left. So if it says you crash your truck, that's your truck. Into a tree or a really big piece of broccoli, and you walk 6 miles east. Here's you crying. Okay? So that's what the picture would look like, and then it says you got scared, and then you walked off in this direction. Well, bearing is a little bit strange. So if I'm going to give you a bearing, which is different from a heading is a degree out of 360. So north is 0, and then one way, or I don't remember which way it is. But a bearing is given using 2 letters. So this would be north 15 degrees west, which means if you were to face straight north, and then you were to rotate 15 degrees west, this angle would be 15 degrees. So what would the angle be created from the truck to your new path? Well, this would be 75 degrees. And when you give a bearing, you either state north first or south first. So this quadrant is north a number of degrees west. This is north a number of degrees east. Quadrant 3 would be south a certain degree west and south a certain degree east. So that's going to be used in the problem. It'll give you some of them will give you a bearing, so you either face north and rotate west or east, or you face south and rotate east or west. The other thing you need to know is that's the ground, and this is some object in the sky, like your big piece of broccoli. Okay, and that's the top. If I draw a parallel line, the angle, we'll make another object over here. The angle from the ground to wherever you're looking at is called the angle of, not ascent, elevation, which is equal to this angle, because the two lines are parallel and they're alternate interior angles. This angle, if you're up high and then you tilt down low, is called the angle of descent. So angle of elevation is from flat up. Angle of descent is from flat down. Okay? And if you just happen to draw right angles here, then you find out that these two angles are the same length or the same rotation, even though they don't have a particular name, at least not one that I know of. Okay? So, let's look at problem number 1. It's not too bad. I'll set it up for you and then I'll let you solve it. And it says round your answer to the nearest mile, which is nice. So lighthouse B is 8 miles west of lighthouse A. So here's A, here's B. A boat leaves A and sails 6 miles. In what direction? We don't know. So actually, well, so if this was 6 miles, the boat could be anywhere in that circle, right? On the circle. Okay. If the bearing of the boat from lighthouse B is south 71 degrees west, how far from lighthouse B is the boat? So from the B, if I look straight south and then I turn 71 degrees, then there's going to be a triangle that connects, well, in this case, it looks like 2, but it depends on the problem. So maybe I should delete that circle so I don't confuse you guys. Okay. So the boat is somewhere on that path, and this is 6 miles. So what is the complement angle to 71? 19. And then I know that this is 8 miles. So I have angle side side. So you could use the law of cosines and create a quadratic and factor, or throw it in your calculator. And if you get 2 positive roots, that means that there are 2 solutions. If you get 1 positive root, that's 1 solution. If you have no positive roots, that would be no solution. Okay? Everybody understands how to do that? Let's look at number 2. You and a friend hiked 13 or 1.3 kilometers due west from a campsite. So that's camp. Hike due west 1.3 kilometers. At the same time, 2 other friends hike 1.7 kilometers at a heading of north 17 degrees west. So if we drew a line straight north and we went west 17 degrees, that's where they end up. and that is 1.7 kilometers. So we don't really care about 17. We want this angle, which is, that angle is going to be, the complement of 17 is 77. And it's asking how far are the two groups. Oh, you have no proof. 73. How far apart are the two groups? So here is side angle side. What do we need to use to find x? Law of cosines will do it in one step. If you used law of sines, that would tell you another angle, and once you knew another angle, then you could find the other side. So the law of sines would do this in one step. So you kind of can use the law of wait, did I say that wrong? Law of cosines is the one you want. Law of cosines will do it in one step. Law of sines will take 2 steps. Okay, but I want to show you number 4, because number 4 is kind of tough. Okay, it's really tough. Two observers are 450 feet apart. Call this guy A, this guy B, and that's 450 feet. And there's a flagpole somewhere between them, right in the middle? Just somewhere in the middle. We don't know where. Flagpole. We'll call the tip of the flagpole C. The angle of elevation from the observers to the top of the pole are 23 and 25. Does it matter which one we put on A? Do we know which is A? Well, what are we looking for? The height of the flagpole, so it doesn't matter. Well, this one 23 and this one 25. And flagpoles are assumed to be straight up and down. Who's closer to the flagpole? Why? I heard 23 and 25. Why do you say 23? Well, if A is 23, what's the angle created by the angle of elevation side and the flagpole? What we need to know is whose angle is bigger. Is that one bigger or is that one bigger? The 23 is going to give a bigger other angle, which means that that person is further from the flagpole. So B is closer to the flagpole than A. No, that's not a question. I just was asking. So we want to know how tall the flagpole is. How are we going to do that? Ooh, is the flagpole halfway between A and B? We know it's not halfway. How do we know it's not halfway? The angles are different. So because the angles are different, we know they're not halfway. In fact, we just figured out that A was further from the flagpole than B. Okay? How's that going to help? We could. Great. What are the other angles? 67 and 65. So let me draw these two triangles. 23, 67, and right. 25, 65, and right. But I don't know any of the sides, right? Or do I? Okay, I know that the entire distance on the bottom is 450. Go ahead. Oh, that would work. Great. So if I look at the triangle as a whole, I actually did it the long way, but this will work. So from A to B is 450, and I know A and I know B, which is angle, side, angle. So I could find either little a or little b, correct? So little a or little b, it doesn't matter. So the sine of 25 over, sorry, I'm not, okay, sine of 25 over little a is equal to 132, sine of 132 over 450. Boy, I did it the hard way. So 450 sine of 25 over the sine of 132. So we can type that in. 255.91. So that's up here, 255.91. And now I can find h using the law of sines. Right? Well, do you want to see how I did it, which is a royal pain in the butt? I'll just show you so that you're smart and you don't ever do this. What I did was said, okay, these are both h. They're the same distance. And I called this x. So if that's x, how big is this one? 450 minus x. So I did a law of sines. Sine of 23 over h is equal to the sine of 67 over x. And then I did a second law of sines on the other side. Sine of 25 over h is equal to the sine of 65 over 450 minus x. Well, I can solve this for h, and once I get it, I plug it in there, which was like 0.44x, and I just cross multiply and solve for x. But Tristan's smarter than me, so don't do it my way. Do it the easy way. Okay, you have 22 or 23 minutes to work on this. I do have the odd answers, if you'd like to see them. Right there. Good luck.